First off, thanks everyone for joining me so early after a big night out. Hopefully everybody had fun last night. My name is Ryan Oattes. As Joe said, I'm the CTO and one of the founders of Kobai. I'll go a little deeper into my background than I normally would. Before Kobai, I was 15 years at General Electric, and I say that to set the context of folks in this room. You know, I'm a tech company CTO at the moment, but Kobai is comprised of people that spent most of their career solving the same kinds of problems that you are in industry. So, in fact, we started the company to solve some of the same problems that are getting talked about at the conference this week. So, Kobai is a semantic knowledge graph. It is native to Databricks. It is closely integrated with AVEVA. And it's designed primarily to enhance industrial decision making, provide better, more immediate access to data. And you can see, answer the question here. We're talking about bringing, Kobai, Databricks, and AVEVA together. But we invested so much in these cloud platforms. We have AI at our fingertips. Why are we not getting better decisions? What are the barriers there? So to answer that question, we sort of first have to talk about, why would we do this? Title of the talk is, connecting AVEVA and Databricks through semantic context. So why would we even try and do this? Today, even in 2026, most industrial data still lives at the plant floor. We have Pi, we have historians, we have tools for process engineers. And bringing that stuff to the cloud, which some of us are doing, requires investment. It requires new products, new platforms. It requires significant time from subject matter experts. And so we only want to do that if there's value in doing it. And a lot of times, value means faster, better decision making. In all of our operations, there are opportunities to save money, go faster, improve quality, whatever. And oftentimes being able to execute on those things means having, the right information at your fingertips, fully contextualized information to answer the right question at the right moment. So this is an old problem. It certainly predates generative AI. Oftentimes it seems like AI should help. There's kind of a tendency to dump everything into an LLM or think that I'm going to get some magic out of this. But often in our experience, that sort of first foray into generative AI highlights the problems more than solves them, right? And we find that we're getting partial answers very quickly, and we want to improve on that. So today, there we go. I'm going to talk about 3 challenges that come up when we're trying to solve these things. The first one I like to call the Brownfield alignment challenge. So how do we get beyond lift and shift when we're taking things from the field and we're bringing them into the cloud, into these sort of cloud platforms like AVEVA or Databricks? We have fleets of assets, but they're built to different standards. They're built at different times. Even the same LNG plant maybe has been expanded in 3 phases by 3 different contractors. And so it's the same equipment, but it looks different. And so, maybe it's completely digitized. Maybe I've even done some of the work in AVEVA Connect to wire it together, but it's not truly integrated because every plant looks different. The second one is context. We have silos of data. How can we bring those things together in a way that is not just wired and connected, but is meaningful, is reusable, and is reachable by every person in our organization? And that includes the rest of the enterprise, not just strictly sort of AVEVA side industrial data, but everything else, in adding sort of full context to the decision making that we're trying to do. So, I always say important decisions are cross-functional or hyper-cross-functional. And so mere connection between this data isn't enough. We need to get to understanding across all this data. And the third one is AI trust. How can we democratize access to this decision-making data without blowing up trust in the data? So we're all impressed by the speed, the immediacy of getting access to data. Some of the challenges, I went to a talk in the room next door about digital twin yesterday, and some of the use cases and challenges are amazing. And we talk about getting it down to, from weeks down to maybe days. AI can take that into minutes or even seconds, but if we don't have trust in what we're getting out, that time savings is essentially useless. So we can't make any decisions based on that. So we'll talk about that a little bit as well. So first, Brownfield. Did that not change? It didn't change. There we go. Everything is digitized. You know, 2026, people have been through with AVEVA products. You know, we're connecting things in Pi, but they've all been built to different templates, to different standards. And so I can absolutely find any particular measurement in one of my plants. But what if I want to do this at scale? I want to find that same measurement everywhere that it applies. And so, you know, I have a cloud level analytic maybe around pump efficiency. Question one is, where are all the pumps in my fleet? And you know, some of the fleets that we've dug into, this is a non-trivial exercise, right? They all look a little different. They've been instrumented differently, called different things. And so off-the-shelf LLMs are actually fantastic at solving problems like this when it is general purpose knowledge. So if you want to find all of the negative Amazon reviews about a given product, that's easy. That's general knowledge. It solves that, you know, quick as you like. But it is different with industrial data, where, you know, some of the tag names in refineries, like, they're as close to random as you might want to contemplate. It's not something that a generally trained LLM is going to know something about. And analytics that we're going to deploy are like jigsaw puzzle pieces. They expect certain interfaces. I have this, you know, notional pump efficiency analytic. It wants to see inlet pressure, outlet pressure, you know, power of the driving unit. So we need to be able to find those things. And we don't have the terminology necessarily known to the LLM to do that. So that's where a product from my company called Kobai Precursor could help. And it is designed to find things that are the same across your organization. It takes it a step up from looking at the labels and trying to guess based on various ANSI or ISO standards what that label might mean. It does it by building context. So I'm going to look at things in the graph. I might find some unit that's come from a smart PNID, and I'm going to look around it. I call it the semantic neighborhood. It doesn't really matter what it is. But I'm going to look, I find this object. We don't know what it is, but I find out soon it has an inlet pressure, it has an outlet pressure, it has a speed, looks a lot like a pump. It's kind of the old, if it looks like a duck and quacks like a duck, might be a duck. So we, in Kobai, I mentioned it's a graph. We build a giant graph of this. A single refinery might have trillions of edges in the graph, and we're finding all of the things that might be the same, and then trying to resolve that down. And so this is why Databricks is core to this. This is the kind of problem that you can only solve if you have access to this massive distributed compute in something like Databricks. And so Kobai Precursor plus Databricks is able to categorize these things, find all the pumps in the fleet. The second problem is context. This is actually the core problem we started Kobai to solve in the first place. You know, maintenance decisions benefit from you know, supply chain data, right? I might want to take my maintenance program and cost it out, or figure out what the lead time is on various parts. And to do that, I need the rest of the enterprise. I need things that maybe go outside of even what's available in the full suite of AVEVA tools. You know, I have customers, for example, that in evaluating equipment failure, they're looking at part supply chains, and they're in a very governed industry. And so they've taken it all the way to looking at the vacation schedule of technicians who are certified to make that particular repair, to make sure that if we're planning this, we need to, you know, make sure we understand the full scope of what's involved in doing this maintenance program. And so what do we need to do? You know, we need to contextualize the data. And first step is integration. And so lots of talks on that this week. You know, we need to wire the data together. We need to have access together. That's relatively easy. The challenge here for us is when you get outside of the scope of one user or one expert, trust becomes a factor, right? I need to bring in knowledge from different world-class experts in supply chain, operations, engineering, whatever those are, and have them kind of work in together. So cross-functionality implies this collaboration, and it implies a need for a common language to get everybody on the same page. So this is where, you know, adding semantics to the context is critically important. Again, as I said at the top, this is an old problem. People have tools that do this kind of integration today. Could be SQL, could be Python, and they all share the issue that the integrations are buried in code somewhere, and you know, that's a tough bridge to cross from a trust perspective, right? If I'm integrated data, it's buried in Python code, it's somewhere in the back of AVEVA Connect or wherever it is, in SQL maybe. It's tough to reuse because it's tough for users to come in and just trust that that is the right answer. So, you know, what's the solution to this? Again, my company Kobai provides a tool called Kobai Studio, which adds a layer on top of Databricks and on top of AVEVA that gets subject matter experts directly in the game. And so our approach is do this entirely codelessly. We have an interface, a lot like a whiteboard. Describe your domain the same way you talk about it in a team meeting so that the terminology matches, the semantics match, the context matches. And because it's visible, everything is really easy to reuse. There's no code to go back and understand. Everything's discoverable to new classes of users. We can push this down to a maintenance technician who has never had this kind of information at his fingertips before. And also, because it is visual, it's easy to inspect. It's easy to trust. You can get an answer, and without having to read a page of code, you can understand how you got that answer. Kobai also uses a graph structure to make it flexible. So this is a very large problem. You might think about these as digital twins that cross many domains, and the graph has the ability to let you grow over time, sort of in an organic method. You can bring together your operational data as a start, add maintenance onto it, add supply chain, sort of grow as you like. And again, this is a layer that we build seamlessly on top of Databricks. And so this is if you're a Databricks user or you've taken advantage of the AVEVA Connect to Databricks pipeline. Kobai doesn't add a piece to that. It integrates seamlessly with Databricks and organizes the data there. So you don't have some extra graph database. You're using all the power and all the access to seamless Databricks AI. The last challenge I want to talk about is AI trust. How can we democratize and accelerate people's access to all this amazing data that we're pulling together? As I said before, if users don't trust what they're getting out, the speed and the immediacy are kind of useless. So I think about it as a couple of communication problems. We have one between your technical data in the plant and the LLM. The LLM has been trained on the contents of the internet, for good or ill, and it doesn't necessarily understand what a rather cryptic tag name means in your data. And there's this sort of gap of getting that data understandable by an LLM. The other communication gap is maybe even more interesting between a technical user from one of your companies, someone skilled in oil and gas, immersed in that field, and an LLM, which is not an oil and gas expert. And the good news is that both of these kind of gaps can be crossed by what we've already talked about, by building in the context, by having a contextual layer on top of your data in Databricks. You can bridge the gap between the LLM. You can teach it how to operate on your data so that it understands questions natively from people who are sort of skilled in the art of asking questions about oil and gas. And again, one thing to highlight on top of this is, Databricks as an example. Databricks has a great tool called Genie. I don't know if anybody has Databricks users in the room, but Genie is their sort of chat to data feature. And one of the things Kobai's been most excited about in the last year is what we call our Genie Accelerator. It's the ability to take all of the context that you've built into a Kobai graph, which is driven by all of the context precursors pulled in from your AVEVA data, and make that available to Genie so that it knows something about the domain ahead of time. You don't have to build these things manually. As you're evolving your ontology in Kobai over time, we're continually grooming these genies so that they're always up to date with the latest terminology, with the latest information, so that when you're asking questions, you can get there very quickly with, again, something you can trust because it's in your own terms. What does this look like in practice? We can walk through a very simple example. I might have a pump 101, has some bearing issues, it's vibrating, and it's chewed up its bearings, it's out of service. And so you might ask questions like, which pumps are seeing similar service conditions? Which pumps are seeing the same vibration issue? Or, which pumps have the vibration issue but haven't seen the failure? These are kind of classic operational AVEVA land industrial data questions. But the next level of questions are, what are the costs of the downtime if I'm going to plan a maintenance program to get ahead of these bearing issues in these pumps? Do I have spares in stock? Where do I have people that can do the work? What's the lead time on doing this? So, properly planning a maintenance program. And so that's the kind of analysis you can only do if, you've digitized your plant data in AVEVA, as many people in this room will have. If you've then integrated it into an analytical platform like Databricks, where you have, seamless access to cloud scale compute and AI. And then we would argue where you've used something like Kobai to connect the knowledge of your organization on top of that in a way that puts the data at the fingertips, not just of technical users, but of every user in the organization. So finally, we think the future of industrial data isn't connected data, it's connected understanding. And that this semantic layer driven by your own teams and understandable by them is critical to the whole enterprise. So, industrial data from AVEVA meets enterprise data and, limitless cloud scale compute, the latest AI in the Databricks platform. And then we combine them with Kobai. We can do things like, onboard our fleets in a meaningful way, enhance decision-making with the full context of the enterprise, not just the plant floor data, and get AI answers that we can trust. Thank you.